In Maya 2014, you can now easily identify new tools and options using the What's New highlight. New improvements to the node editor allow you to easily customize the view of the nodes, for example by filtering their attributes or customizing their colors. In addition, creating connections is now simpler and you can view assets in the node editor. Several hotkeys have also been added to simplify your workflow. The new file path editor lets you manage your scene's file paths directly in Maya. The file path editor lists and diagnoses the resolution state of all files being used in Maya and provides you with tools to repair pathing issues. The repath window, replace string tool, auto resolve window and actions preview window lets you repath files and preview repathing changes before they occur. In addition, the file path editor can also be used as a scene preparation tool. If you are preparing a scene for use by somebody with different directory, structure or platform, you can path to non-existent files. The Move tool and Scale tool manipulators now have plane handles that let you transform objects along multiple axes. In Maya 2015, the node editor gets more improvements. Here you see a comparison with the look in Maya 2012. Improvements include a customized attribute list, new zooming and graphing methods. The outliner and the attribute editor have been updated. You can now hide objects in the outliner and of course also unhide them. New hotkeys give you an alternative to scroll bar navigation in the outliner. Quickly pan through long lists of objects at normal speed with Alt and middle mouse button or at an accelerated speed with Control, Alt and middle mouse button. In the attribute editor, you can now press Enter on the numeric keypad to complete an edit and highlight the new attribute value, making it easier to enter new values. Like in the outliner, you can now scroll through long lists of attributes using Alt and middle mouse button and Control, Alt, middle mouse button for higher speeds. In Maya 2016, the user interface has been overhauled and modernized. It now has new flat scalable icons for high and low resolutions with simple and easy to recognize colors. Everything is now flatter and less skeuomorphic. The menus have been reorganized into 5 menu sets. There's a consolidated modeling menu, one deform menu for modeling and rigging, and a generate menu with XGen paint effects and cloud services. The new hotkey editor gives you the ability to create context-specific hotkeys. It also shows you which keys are already assigned and which are still available. And if you're lost, just open the Find menu option in the Help menu to look for any menu item you can't find. In Maya 2016, building and editing materials in the Hypershade is now more artist-friendly and intuitive with a revamped user interface that optimizes your look development workflow by providing the following features. A new node editing interface is available in the work area, allowing for simplified workflow when creating shader graphs. Nodes are created in a streamlined custom view where only the commonly used attributes are displayed. Soloing is supported, allowing you to isolate the output of any shading node to see its contribution without having to modify your shading graph. You can dock, undock and rearrange panels in the Hypershade and create a layout that best suits your workflow. The new content browser is your one-stop center for finding examples, scenes and other content to build your scenes in Maya. It replaces the visor. You can navigate your files in your Maya projects, local and network directories and sample libraries, then drag and drop them into the View panel. You can now use the outliner to work with a new render setup system, materials and sets. You'll also notice some ease of use tweaks to the outliner menus and outliner contextual menus. You can filter objects based on the render layer. The new Assigned Materials filter displays the materials assigned to each object, and you can right-click a material node to access several new commands. In Maya 2017, Workspaces define the configuration of windows and panels. You can modify the current workspace by opening, closing and moving windows and panels, as well as docking and undocking them by dragging and dropping. These changes are automatically saved as overrides to your current workspace. Workspaces are more flexible than panel layouts because you can move or dock almost any window or panel almost anywhere in the user interface. In addition, workspaces are stored as separate files in your user directory instead of in scenes. If for any reason you want to revert and discard your changes to the current layout, select Windows Reset Current Layout Name.
So here we're going to be looking at Viewport 2.0, which is Maya's high-performance hardware accelerated display. It basically solves all the features that a lot of software renderers can do, but with your hardware. It covers all sorts of things like Maya's N-Hair, N-Cloth, Maya's Paint Effects, the Toon Shader, projection shaders, and all these things go into making Viewport 2.0 having a complete feature set to allow it to be Maya's default render viewer of choice. The Viewport 2.0 has traditionally been the best viewport mode for performance. So the first thing we want to look at here is the basic performance. So we have our character crawling out of the water, and we want to improve that time it takes him to walk out of the water. So within the Viewport 2.0 options, we can go in and turn on vertex-based caching. So what this does, it takes into account the skin clusters, any other deformers that you've got in your character, and it's going to cache it all out and give us much better results the second time we play through this animation, as it's just storing those vertex changes on the GPU. So as we see here, the second time it plays through is playing it now at real time. So the other things we want to look at here is features like ambient occlusion, which can also be viewed in the viewport. So this is a screen-based ambient occlusion. So we see the nice little shadow areas and the ground contact areas are now showing up nicely in this example. Next we're going to look at here is things like hardware-based anti-aliasing, which gets rid of all those jagged edges, so we're getting much closer to the final finished render that we'd expect to see. So now we're super sampling the scene, so we're up to 16 samples here in an OpenGL scene. So this shader was generated using shader effects, which are using a DirectX 11 OpenGL shader, which gives us a nice skin shader, which is why we're getting that quite fleshy look to this. So Viewport 2.0 also now supports particles, so specifically sprite-based particles. So if we play this back, we'll see that the result we have here, we've turned this particles type to sprite, which allows us to take all the information from a shading network, apply it to that, and it'll accurately represent itself directly in the viewport. So what we've got going here is a really simple shader that we've got applied to our sprite-based particles, and this allows us to be able to view it as an accurate representation within the viewport. So an additional new feature of Maya 2017 is that the viewport now supports OpenGL displacement. So this means that we can get accurate representation of what we would expect to see with a displacement map in the final render, but within the viewport. Now this eliminates the need for proxy geometry and that sort of thing. So in the example here where we see our character walking over a landscape, we can see that his feet will now be in contact with the correct height of the landscape based on the displacement map that has been applied here in the viewport. As well as the displacement map, we've also got support for open subdiv. So what this allows us to do is to be able to have a smooth character mesh without any jagged edges to give us a much closer representation to the final character that we would see in the render. The benefit of open subdiv is that we don't get that performance hit that we would have traditionally when subdividing our characters. So we get much faster results.
Maya 2015 can now read OpenEXR files that are created by OpenEXR 2.0 library. The UV tiling feature allows you to use single file texture nodes to load and render multi-tile UV textures. In Maya 2015, the node editor gets more improvements. Improvements include a customized attribute list, new zooming and graphing methods. A new simplified workflow is now available for rendering PTEX in Mental Ray. The extension release of Maya 2015 features a new color management system. This allows for consistent processing, interpretation and communication of colors throughout the mixed pipeline. In Maya 2016, building and editing materials in the Hypershade is now more artist-friendly and intuitive, with a revamped user interface that optimizes your look development workflow by providing the following features. A new node editing interface is available in the work area, allowing for simplified workflow when creating shader graphs. Nodes are created in a streamlined custom view where only the commonly used attributes are displayed. Soloing is supported, allowing you to isolate the output of any shading node to see its contribution without having to modify your shading graph. You can dock, undock and rearrange panels in the Hypershade and create a layout that best suits your workflow. You can render shaders, bump maps or 2D textures in real time in the new material viewer. You can create multiple tabs in the work area with its own set of nodes displayed. This way you can work with multiple shader graphs and edit them simultaneously without the need to regraph. Material editing is simplified in a property editor that displays shading node attributes in two ways: the classic attribute editor layout or the look dev template view with a simpler layout optimized for look development workflows. The new render setup system in Maya 2016 replaces the legacy render layer system. This simplifies the management of complex scenes. It brings a modern approach to adding shot-based overrides to scenes, and you can easily generate templates for the setup of a shot and propagate these setups from one shot to another. The new light editor simplifies light management. Use it in conjunction with the render setup system to apply overrides to the lights in a layer. It provides a convenient interface to create, group and position lights and enables you to adjust attributes for multiple lights in a single editor. Arnold for Maya is now the default renderer in Maya 2017. It replaces Mental Ray. You can use Arnold together with Maya's Hypershade with the render layers and the light editor. The list of rendering improvements in Maya 2017 includes hierarchical collections, interactive rendering of sequences, and a new hair geometry in the material viewer of the Hypershade.
Now we're going to take a look at some of the effects developments that we've seen in Maya over the last few releases, starting with a brief overview of what Paint Effects is. It's essentially a brush-based tool that allows you to create 3D elements in your Maya scene. It can also be used to create textures from the 2D part of the brush tools. It's pressure sensitive, so it can be used with a Wacom, and also has a common interface with similar painting tools such as the Sculpt tool or the weight painting tool, so it will feel very familiar to users. We're just going to look at a simple example here of how Paint Effects can be used to create some geometry in the scene. So we're going to paint some flowers here by this oil can, and then we're going to turn the oil can into a collision object for the flowers so we can see that it interacts with the object that we've just painted. We can also turn the oil can into an attractor. Now we're going to look at a further example of how we can use the Paint Effects tool to paint directly onto this fan using the Vine tool. Another example of Paint Effects is the grass brush. If we see this in action, we can see that we've painted a bit of grass, but it doesn't quite adhere to the surface, so we just turn on the surface snap button here, and then it will adhere correctly to the normals of the surface. If we want to add a bit of noise and different effects to the grass, we can do this here, and we can see that we get different results where the grass will start to randomize itself, and we can use various attractors and offsets to determine the behavior of the grass. Maya 2014 saw the addition of the bullet solver. This is basically a dynamic effect that we can apply rigid body solvers to different objects in your Maya scene. Here we can see that as we move the objects around, it will change the effect of the rigid body solver. The beauty of the new system is that we can layer all sorts of different effects on top of each other, so you can have multiple effectors determining the behavior of your solver. So here we've got a volume axis inside of this vortex shape and several effectors in play to create a vortex style simulation. So we can apply this to our rigid body objects. It's quite an art directable feature, so we can actually apply an animation to this vortex and drive it where we want to and see the results on our rigid body objects. If we play this back now, we can see the effect that it has on our objects in the scene. Here's a further example of bullet in action. We've got some destruction applied to this column here, and we're going to add some gravity and basic velocity to the ship so that as it collides with a pillar, we see the full result of the rigid body solver in action. Maya 2015 saw the addition of Bifrost, a powerful new procedural effects platform originally derived from the Naiad plugin. Here we're seeing we can use deformed geometry to actually drive our simulation, so this is called guided simulation. So we see here as we scrub through, the movement of geometry is affecting the movement of the particles that make up our fluid sim. This shows when you apply different deformation to the geometry, we can get this rolling wave effect directly on our fluid sim. And this is all coming from the geometry as a starting point. If we scrub through here, we can see exactly what effect the geometry is having on our fluid sim. Maya 2017 saw the addition of motion fields. Now this is a very simple way for you to art direct your fluid simulations. Here we're seeing some examples of the kind of dynamics we can achieve very easily. With this example here rolling through the wave, we're simply just animating the motion field through this volume of fluid, and we can see the incredible results that we're getting. It just allows the user to be able to work in a very natural, realistic environment, but achieving incredible results very simply. It just really puts the control back in the hands of the artist. This is an example of the aero solver in action. And this is all captured from the viewport, so you get a very good representation. As part of Maya 2017, we also have our Ocean Simulation System, or BOSS. This allows us to use collision objects with our geometry to create a ripple wave effect. We can also add spectral noise to this, so we get an incredibly realistic effect on the geometry, which can then be used to drive our fluid sim through guided sims. A scene like this would take roughly 20 hours to simulate from start to finish.
Maya 2014 extension, we introduced XGen. XGen includes an interactive grooming brush set that lets you create and groom all types of hair and fur. XGen lets you generate curves, spheres and custom geometry on the surface of Maya polygon meshes. You can then use XGen geometry instancing to create and groom hair and fur on characters. You can also populate large landscapes and environments such as grassy savannas, forests, rocky terrains and debris trails using XGen archive geometry. XGen uses PTEX maps to control the placement of instance geometry. It has a library of expressions to generate and randomly scale, position and color default primitives and custom alembic-based archive geometry. You can then export geometry from a Maya scene and then instance it back in as XGen archive objects. In Maya 2016, the performance of the hair preview has been improved massively. You can now save hair and fur grooms and instance geometry as XGen presets. XGen presets include all the description settings such as guides, modifiers and shading networks in one file. This makes them ideal for transferring and sharing grooms and instance geometry within your production pipeline. XGen archives can now be viewed with all the textures and shaders in the viewport. The spline-based guides that control the shape of the hair can now be modified using Maya's new sculpting brushes. Groom edits can now be saved to files, which is a first step into layering edits. Guides can be animated and can also become dynamic objects to control the hair in the animation. New shading nodes provide more ways to customize your XGen hair shader network. You can now color and texture XGen hair and other primitives using custom shaders or Maya standard materials. In Maya 2017, grooming all types of hair and fur in XGen is easier and faster using interactive groom splines and the interactive grooming editor. This new feature set consists of intuitive brush-based tools that provide greater control and accuracy for styling and posing hair and fur. A layering system in the interactive grooming editor lets you combine several modifications of the hair and blend them independently. The sculpt modifier layer lets you blend, layer or key the effects created by the interactive grooming tools. Other interactive grooming modifiers provide additional options for shaping hairs and enable you to animate or simulate your hair grooms. These nodes compute on your system's GPU so that your brush strokes appear in real time, providing an interactive workflow that does not require disruptive preview generation. All of the interactive groom spline data is saved with a Maya scene file without using additional PTEX or XPD sidecar files. Maya 2014 now includes a modeling toolkit that is designed to increase the speed, accuracy and efficiency of your workflow. The modeling toolkit integrates selection and transformation tools within a single window and keeps tool switching to a minimum. Features include tools for mesh editing and creation, pre-selection highlighting, vertex locking, slide components, and fully integrated ring and loop selection. While the toolkit adds workflows on top of existing Maya modeling features, it does not diminish the capability or usability of Maya's native toolset. Maya has adopted a faster, more efficient algorithm for reducing the number of polygons in a mesh. This improved algorithm reduces the complexity of an object by removing unneeded vertices without affecting the object's shape. New options in the Reduce window give you more control over your reduction. You can now keep your existing polygonal lines, reduce your mesh by a percentage, vertex count or triangle count, and export an index vertex map. The new crease set editor in Maya 2014 offers greater control over selecting crease components and editing crease values. It is an improved alternative to the existing crease tool and crease selection set commands. Eliminate distortion with the new Unfold 3D algorithm. Unfold 3D is a faster, more reliable alternative to the legacy Unfold algorithm. In one unfold operation, the new algorithm eliminates degeneration and distortion even at complex corners. New icons in the UV editor toolbar apply a shader to your UV mesh, helping you identify distortion in your UV layout. The checker pattern shader makes it easy to see if your UVs are spread evenly, and the distortion shader lets you spot squashed and stretched UVs. You can now work with multi-tile UV textures that have been created in other applications, including Mudbox, ZBrush and Mari. When you load multi-tile UV textures, the UV editor automatically detects the number of tiles and uses the original grid tile layout. Each tile is labeled with the name of its corresponding texture file. New options and tools give you greater control when you make selections in the UV texture editor. You can now create UV shells directly from selected components. The new toggle shell border commands highlight sets of connected edges in different colors, and you can now double-click a face to select the UV shell. In Maya 2016, artists can now shape models more artistically and intuitively using the new set of fully featured sculpting tools. Simply select a tool from the new sculpting shelf, adjust the sculpting tool settings, and move your cursor across the model to make a stroke. For a more complete shape authoring experience, use the sculpting tools with blend shapes. Updates to the blend shape editor make creating and editing blend shape targets easier. Click new buttons in the editor and on the sculpting shelf to create, edit and remove blend shape targets without adding new meshes to the scene. In Maya 2016, the modeling toolkit integration has been completed. The streamlined modeling toolkit no longer contains redundancies like duplicate tools and options, and the settings that remain in the panel are fully integrated into Maya. The power button in the tool has been removed. The modeling toolkit is now always on. The new in-view editor displays a customizable subset of a node's attributes. An editor appears for some modeling operations, letting you adjust attributes directly in your scene instead of opening the channel box or the attribute editor. The UV editor in Maya 2016 also includes a complete set of brushes to modify the UVs. The UV grab brush lets you grab the UVs with an adjustable radius and fall off. When you hold the control key, you can even rotate the UVs. The unfold brush lets you apply the new unfold algorithm locally. This is very useful after modifying only part of the UV shell. The optimize brush then lets you reduce tension in the UVs and optimize the result. There are even cut and sew brushes that let you cut across UV shells and sew the edges together without any difficult selections. The freeze brush lets you interactively pin or freeze the UVs. When you hold the Shift key, you can smooth the freeze values. Partly frozen UVs only pick up part of the applied transformation. There's even a 3D UV grab tool to allow you to modify the UVs directly on the 3D surface. The SVG tool now enables you to copy and paste scalable vector graphics files into Maya and generate 3D meshes. This allows for seamless interoperability with vector-based 2D design applications. The workflow, which is similar to 3D type, allows you full control over things like bevels, extrusions, materials, and animation. The 3D type tool makes it easier than ever creating branding, flying logos, title sequences, and other projects that require text. 3D type allows artists to create easily editable, non-destructive, multi-line deformable type with full control over the way it looks, including bevel, extrusions, materials, and animation. In Maya 2016 Extension 2, there are several improvements around symmetry and in the new UV editor. When you turn on symmetry while components are selected, Maya automatically selects the appropriate mirrored components. There's also a new heads-up display that displays the current axis of symmetry when one is active. In addition, symmetry support has been expanded to a number of tools, including Multicut, Connect tool, and the Bridge tool. You can also use the new Flip command to swap the position of components across the axis of symmetry. In the UV editor, there is now a UV symmetrize brush. Simply select the symmetry edge and use the brush to symmetrize regions of the UV shells. New options in the Layout UV function include the ability to pre-rotate UV shells according to their shape, to limit the layout to only part of the UV tile, or to use several tiles for the layout. You can use the new Auto Seams command to automatically select or cut appropriate seams for your meshes or UV shells. This saves you from having to select and cut edges manually, while also ensuring that edges aren't missed accidentally.
Now we're going to look at some of the animation features ranging from Maya 2014 right the way through to Maya 2017. Maya 2014 saw the addition of Grease Pencil, a great new tool to allow artists to be able to do draw-overs directly in the OpenGL viewport. Now this is a 2D style interface to allow artists to be able to do different drawings on different frames and then scrub through the results. Here we've sped this up slightly, but you can see the artist drawing different versions of the character on different frames so that we get the impression of animation. This is to allow artists to be able to evaluate their work and do draw-overs to get the best out of the creative process. There's also a ghosting mode to allow you to view up to 5 frames before and after the drawing that you've just created. 2015 saw the addition of Atom, a brilliant new animation transfer tool to allow you to store files externally and seamlessly transfer animation from one animation scene to another. We also saw improvements in the graph editor, both in performance and in usability. Maya 2015 brought us the addition of the Tracks clip matching tool. Now this is a clip-based approach to animation to allow users to seamlessly blend between different animation clips, designed primarily for motion capture. 2015 also saw the addition of Alembic caching. In Maya 2016 we saw the addition of the Profiler tool. Now this tool allows users to be able to evaluate the rigs and see where the performance hits are. It gives a very visual sense of which nodes in your rig are taking up the most expensive performance. Maya 2017 saw the addition of the time editor. Now this was the natural progression from Tracks, except now it has much more advanced blending and many more features, including simple looping, stretching, compressing, and the ability to still animate in layers over the top of the clips as you would with the standard animation layers. It has much more advanced blending, meaning that your 2 clips could have different start and end poses, and it still allows you to blend so that it seamlessly matches the character clips without the user ever knowing that they had different start and end positions. The other benefit to the time editor is the ability to be able to mix and match different body parts. So you could have some animation coming in for the legs and different animation coming in for the arms and match them seamlessly. Now we're going to look at some of the rigging improvements over the last few versions. Maya 2014 saw the addition of projected center joint placement. Now this is a very simple way for us to be able to turn on projected centers, and what this does is evaluate the volume of the geometry that you're trying to place the joints on and give you a center to snap to. By this we mean looking at the arm here, it finds the natural center of the arm and the natural center of the fingers to allow us to place the joints accordingly. This really does speed up workflow when placing joints. Maya 2015 saw the addition of geodesic voxel binding. Now this is a very efficient algorithm for skinning your characters. Gone are the days where the vertices might struggle to figure out exactly which joints they should be binding to out of the box. Geodesic voxel binding gives you a brilliant new skinning resolve straight out of the box. Maya 2016 Extension 2 saw the addition of the Quick Rig tool. Now this looks at a mesh, analyzes where it thinks the pivot point should go, and creates a human IK compatible skeleton for us, complete with geodesic voxel binding. So it really is a one-button solution to rigging, and it's fully motion capture compatible. The other benefit to this tool is it does still have a step-by-step mode, allowing us to go in and make some refinements if necessary, for instance increasing the number of spine joints, or just addressing the pivot points. We can also mirror the pivot points from one side to the other. The other benefit to the Quick Rig tool is that it's a great way to get director approval, perhaps putting this tool in the hands of your modelers, for example, and they just want to pose the character. Leading on from this takes us to the Pose Editor tool. Here in Maya 2016 Extension 2, we have the ability to take the rotation from a joint and use it to drive a corrective shape. Now, the benefit of the way we deal with shapes now in Maya 2016 is the ability to be able to do our sculpts directly on a deformed mesh regardless of what deformers are already in place. Here we see we've taken the rotation of the arm joint, we're trying to fix the problem pose and adjust the volume, and already this shape will be connected to the rotation of that joint. So as we rotate the arm back down, we'll be able to see the effect of this blend shape instantly. So we turn off edit mode and we can see the results straight away. We even have the ability to create additional poses and then blend seamlessly between the different poses. This leads us on to the new shape editor. And this has had many enhancements over the previous way of doing shapes in Maya. We can now mirror shapes very simply, we can create in-between targets, and we can even create combination shapes. We can also export shapes as a .shp file, and really this just simplifies the workflow from start to finish. So you could now just edit your shapes by simply clicking the edit button, and it will allow you to update the shapes. Now with Maya 2016 we saw the inclusion of Mesh, our brand new tool for motion graphics. Here's a short video showing examples of the kind of work that can be generated using Mesh. Now there's all sorts of uses for Mesh, whether it's traditional motion graphics or even things like modeling. It can be used for complex modeling for things like chainmail. It can even be used to generate landscapes or a forest environment. Then there's all sorts of features and behaviors that you can apply to your instances within the Mesh network. Whether it's just basic noise, different sine wave signals to be able to generate different kind of behavior. Mesh can handle all of this within the Mesh network. Here we're seeing audio being plugged into the extrude operator on a model. So you get a graphic equalizer style effect on a piece of geometry. In Maya 2017 there's a Mesh breakout node which allows us to be able to plug the behavior from Mesh into any aspect of Maya, whether it's things like joint rotation or blend shapes for example. As part of the motion graphics workflow we now have a vector graphics import function via the SVG node. This allows us to copy and paste directly from Adobe Illustrator straight into Maya. This is perfect for getting logos from your clients. Here we're seeing the vector graphics used to generate some basic 3D geometry. The beauty of Mesh is that it's all procedural, so it's very easy to set up your animation and then change it out. Here we're seeing some text changing to the word motion, yet it keeps all of the procedural effects that we've worked so hard to set up. Here we see our final showpiece from Mesh, done for us by Mainframe, the original creators of the tool, really showing off what it can do.